Hi, I'm Reggie Townsend. I am the director of the SaaS data ethics practice. In brief, our job is to make sure that wherever SaaS software shows up, that it doesn't hurt people. Moreover, wherever it shows up, that it helps people to thrive. So I'm super excited to be here today. I've got Ali Delone, one of the data scientists on our team. Say hey, Ali.
Hello, everybody.
And Ali and I are here to talk about bias. I think the title here is you got 99 problems and bias is number one, right? So let's dig into the number one problem that we believe data scientists are contending with. But first, let's talk a little bit about the data chain of custody, and then we can layer in where bias shows up. So the data chain of custody should probably isn't very new to most people who are looking at this segment. It typically shows how data flows into and out of an organization. On the far left side, we look at how information is ingested via people, process, structured, unstructured, and so on, then goes into a staging and preparation phase. And then finally, we might do some modeling, we might do some interpretation of some sort. And then at the tail end, we have to have conversations about how we dispose of the data, how we share or sell the data, et cetera. Ali, I know this is a very familiar territory for you. You've dealt with ingesting, modeling, disclosing of data, and so on. What are some of the natural kind of wrinkles that you encounter as you're dealing with this flow?
Yeah, so I think what a lot of people who aren't necessarily technologists don't always realize is that blue chunk, that the ingestion of the data, the acquisition of the data, the pre-processing of the data, that takes up probably 80 to 90% of a data scientist's time. And throughout the processing of the data, a lot of things can potentially go wrong as it comes to bias. And sometimes it's not something that the data scientist will explicitly know about unless they have sort of an area of subject area expertise available to them. And so sometimes they won't have the ability to know that there are potential problems with their data without that additional support. So that's definitely the most time-consuming process, is getting the data ready for analysis. And then, of course, once we dive into the actual modeling, there are sort of plenty of other issues that can sort of arise. But I think the stickiest of situations, really happens, I think, at the beginning of this process.
Got it. So why don't we dig into a couple actual bias examples? So we've done a lot of the work in terms of showing where biases typically show up. Now, a couple of caveats, right? Like these don't represent every single bias that exists. However, we do think it's a good illustrative example of where biases show up in this data supply chain or chain of custody. And we recognize that some of these biases might show up in multiple phases throughout the data chain of custody. Is that correct?
Yeah, definitely. I think there are probably some more so than others that can definitely appear in more than one place.
Yeah. Well, let's dig into it. So we've got, uh, you know, a large chunk in the middle. I want to dig into the middle. A couple of them jump off of the page to me that may not be very typical to most folks. So let's talk about them. So exclusion bias. What is that?
Yeah, so exclusion bias. So this happens in that data cleaning, pre-processing stuff that we were talking about before. So this is when variables are excluded, either because the data scientist thinks that the feature is irrelevant for some reason, or maybe they think it needs to be excluded for some ethical reason. And the first step in the modeling process really should be knowledge discovery. So if the data scientist skips this step, it's very possible that there are variables that are highly related to the outcome that they otherwise may not have realized. And, It's also possible that they're sort of injecting their own bias into the process because they just don't think something is important. And so, what can sort of end up happening is then you can worsen your model performance because you thought the variable wasn't important and so you removed it. So this can also happen in a way where the data scientist had all of the right intentions, right? So unless you have the appropriate justification to do so, sensitive variables like race, gender, language, etc., things that you can't necessarily change about yourself, these are things that shouldn't be included in the algorithms themselves. And so as a result, sometimes what will happen is data scientists have a preconceived idea that these variables should be completely removed from the analysis. But what happens is if we remove sensitive variables from the analysis altogether, then we won't be able to evaluate our models for bias by comparing average predictions, within those different subpopulations.
Yeah. So I get that. There's another one here that just kind of jumps off at me, which is this notion of hindsight. What does that really mean from a practical perspective?
Yeah, so hindsight bias is also sort of commonly known as data leakage as well. And so this happens when there's an accidental presence of information in the training data that legitimately wouldn't be available to you during production. And so sometimes there can just be an accidental use of test data or outcome timeframe data. So one really good example of this, if any of you have ever seen the second Back to the Future movie, is when Marty McFly travels into the future and he wants to buy the sports almanac, right? And he wants to bring it back with him. But it's sort of advised that he shouldn't do that. And it turns out that Biff is his name, right? I think that's what his name is. He ends up taking that information or taking the almanac and sort of bringing it back into the past to his past self. And so now his past self has access to information that he really shouldn't have had access to, right? And so, and this is really sort of relevant in the stage of modeling as well, because what can happen is if you're not careful, outcome information can actually then leak into your training data. And so then when you go to then deploy your model, then, some negative consequences can happen. And it doesn't necessarily always make sense, and it's not quite generalizable to that deployment data.
So it's like the outcomes being fed back end up perpetuating a different reality, if you will, that may in fact be harmful if we're not careful. Is that fair?
Right. Yeah. It's knowing the future when you shouldn't actually know what the future is during the modeling process.
Gotcha. So how does that then differ from like selection bias?
Yes. So with selection bias, so this can happen, and I would actually argue this is probably one of the trickier ones to deal with. And this is the one I think that you really do need sort of a domain expert to really help you figure out if this is something that's happening in your data, because it's not always as obvious, I think, as some of the other types of bias. So this occurs when individuals or groups in a study or in your data set differ in some systematic way from sort of the rest of your data set. So let's say that you're a doctor and you want to get an understanding of the way that your patients perceive you. And let's say that you decide to administer a survey through an online patient portal that most of your patients already use to manage their care. And this is sort of what a lot of patients use to make appointments and to communicate with you, get lab results, that kind of thing. So do you have any guesses as to why this might be problematic?
No, that's why I hired you.
So the thing that can be problematic with this, of course, is that not all of my patients, they may not be using the online portal, right? And so if we think about what are some of the systematic differences between the people who may and may not be using an online portal, maybe then you only receive feedback from, say, your younger patients. Maybe some of your older patients are sort of more inclined to use, paper to communicate with you, to use, the just general phone communication. And so all of a sudden, any kind of data that you collect on patients, they're only going to be the patients that are more tech savvy.
Yeah, no, that totally makes sense. So, we've talked about a few biases and what they are. Let's talk about why any of this matters, right? So, do the proverbial step back. In our world, as we're dealing with the notion of data ethics and trying to work on a trustworthy AI platform, what we're ultimately after, right, is to ensure that these kinds of biases are able to be properly flagged, alerted, et cetera. And I know you do a lot of work in that space, working with our product management and engineering teams to make sure that our platform is reflective of these, I'll call them values or principles, to ensure that these biases are, again, able to be alerted and properly remediated. Yeah.
Yes, absolutely. And I think too, that's an area I think that we do a really good job in, especially with the Via4 platform, is we have a lot of wonderful features built in already to help us to detect a lot of these different type of biases.
Mm-hmm. Yeah. And so, and again, I go back to this notion of a trustworthy AI platform. Our goal is to make sure that our platform, or Via4 in this particular case, is adequately resilient so that our customers have a platform on which they can build responsible AI applications ultimately, right? So I think it would be a great idea for you to show a few examples of how some of this stuff actually manifests itself in the platform. Does that make sense?
Yep, I think that's a great idea.
Okay, let's do it.
Before I present this demo, I want to preface our discussion with some assumptions. This demo was constructed under the assumption its audience would have a general, working knowledge of Model Studio. Additionally, I'm less concerned about the precision of the modeling results and more interested in walking you through the thought process of a data scientist and how to leverage the features in Model Studio to detect different types of bias. Now that we've discussed different types of bias and how it can appear in the data chain of custody, I'm going to demonstrate some of the features included in Model Studio that can help a user detect some of these biases. To do this, I'll be using the Titanic dataset, which includes all Titanic passengers and whether they survived the shipwreck, some demographic information, and information about their ticket class. So for many data scientists, the Titanic dataset is what they use in their very first modeling project. Many folks are familiar with the Titanic shipwreck, and we know that there were systematic differences between those who were more and less likely to survive. The goal of this demo is to create a model that can predict whether a passenger survived the shipwreck and to demonstrate how you might detect different types of bias using Model Studio. So here, the first thing that I want to highlight is the ability for you to be able to create two separate pipelines. What this allows us to do is it prevents us from falling into the trap of exclusion bias. And as a reminder, this occurs when variables are excluded from an analysis because it's assumed the feature isn't important or it shouldn't be included for some reason. In this model, if we go back to the Data tab, we can get an understanding of the input variables that are included at default. So here we can see there are 10 variables that are included as inputs, and we have one target specified. But what you will see is that the age category and gender, both of these are rejected. So these will not be used as candidates for modeling. And I'll talk a little bit about what this assess for bias checkmark means in a little bit. So here we can see that the age and gender not included pipeline does not include age and gender. However, we can click over to this second pipeline and open this Manage Variables node. And here we can actually specify that we do want to include age and gender. So this allows us to run two separate pipelines without more than one project. The next type of bias that I want to highlight is hindsight bias. So we also have the ability here to create a data exploration node. When we open up this node, we get a lot of wonderful descriptive information about our data set. We can see that there are a little bit over 1,300 observations. And what I want to highlight here is this graph. So this allows us to get an understanding of the distribution of our outcome, which is survival, by each of the variables that are included as inputs. One thing that I realized while exploring the different distributions was that there seems to be some kind of a relationship between how long your name is and the likelihood that you survived the Titanic. There may be a number of reasons why this could be the case. It could be the case that because your name is long, perhaps you're more distinguished, and perhaps you can afford a ticket in a higher class on the ship. But what if there's something else going on here? What if there's hindsight bias that's happening? If I am a passenger on the Titanic, I survived the shipwreck, and I get back to land, I might notice that the name that was recorded on the manifest was incorrect for whatever reason. I, because I am alive, have the ability to correct that information, and because I want to be featured in a local newspaper perhaps, I want to make sure that it's correct and detailed. Of course, for the folks who did not survive, they don't have the opportunity to correct the information about themselves. So again, whether or not this pattern is true or not, because this information was displayed to me automatically, it led me to think about some questions that I probably wouldn't have thought about otherwise. The next thing I want to highlight is the ability for you to assess bias for the variables that you're interested in. So here, I'm interested in learning about how the model performs and how fair it is for both age and gender. And here we can see over on the right-hand side, there's an option to check whether or not you want this variable to be assessed for bias. Because I checked both of these variables, now when I go into the pipeline and I open up one of the results for our modeling node, this Fairness and Bias tab appears automatically. The first graph that I want to highlight here is the prediction bias graph. So here, prediction bias represents how much greater the model's probability to predict the event is for one group over another on average. And in fact, I want to highlight gender first. So here we can see that there's a very high prediction bias between males and females. On average, the predicted probability for survival is about 61% for females, and it's only about 27% for males. Next, I'm going to navigate to the age category. And so here we can see that of the passengers that were aged 0 to 18, they had the highest average prediction for the event, which in this case is survival. And interestingly, we also see that for the people who were aged 42 to 80, they also had a relatively high average prediction rate. And this isn't something that I initially expected. This could be due to the fact that perhaps frail folks were actually brought onto the lifeboats sooner than I realized. But this may also be virtue of the fact that folks who are in this age range may be more able to afford the higher class tickets. And we know that folks who are of a higher class were more likely to survive. The last thing that I want to point out here is this missing age category. And so we'll see that this group actually has the lowest average prediction across all of the age groups. Why might this be the case? This may be similar to what we were speaking to earlier about the length of somebody's name. This might be because for the folks that have a somewhat higher average predicted survival rate, if they survived and they made it back to shore, they will be more likely to update their information. But what if there's something else going on here? Maybe there's actually a systematic difference between the people who provided their age and the people who did not provide their age. So in fact, there may be some kind of selection bias that's taking place here. Because of the automatic output that we can see here, it's leading me to ask the questions that I should be asking to make sure that my data set is not subject to selection bias. The next graph that I want to highlight is the performance bias graph. Performance bias is a representation of how accurate the model is for one group over another. So not only are females more likely to have higher predicted likelihood for survival, the model also more accurately predicts whether females would survive, which is represented in the performance bias graph. Most notably, the true positive rate for females here is 95%, while the true positive rate for males is only 17%. And of course, what that means is that 95% of the females that were identified as having a high likelihood of survival did in fact survive. But only 17% of the people that were identified to survive among the males did survive. So we can see here that there's definitely a disparity that's happening between males and females. The next thing that I want to point out actually relates to the way that I decided to bucket the age variable here. So because of the way that I bucketed age, I may actually have subjected myself to a little bit of pre-processing bias. So again, this occurs when data or a variable transformation contributes to a systematic disadvantage. I created a variable that buckets age based on the quintiles in the data. And based on what we know about the people who were more likely to survive the Titanic sinking, we know children were among the first to get into the lifeboats. The quintile method added everyone between 0 and 18 into the children category. But in fact, after doing a little bit of quick research on this, it turns out that you were only really considered a child if you were 12 or 13 at most. So sometimes, and I would argue probably most of the time, qualitative information such as this can be critical when creating variables for modeling. Because had I appropriately done that research ahead of time, I may have created an age category that was 0 to 12 or 0 to 13, and my results may have actually looked a little bit different. I want to leave you with one final consideration. We've talked a lot about the accuracy of our models, but it's important for us to weigh both the fairness of our models as well as the accuracy in our models. And we are currently working on functionality for you to be able to do that fairness comparison directly in Model Studio. In the meantime, what you can do is you can scroll down to this bias metrics table. There's the option for you to be able to download this data, and then you can import this data directly into VA. Because I want to weigh the fairness and the accuracy of my model, I also want to be able to output the scoring data that came out of the model as well. So here I have the ability to create the Save Data node, and then this will automatically save the data with the scored model information. What I did with this information is I imported this into Visual Analytics to do a pipeline comparison. So here on the top portion of the screen, we can see the results when we include age and gender in the model, and we can see the results on the bottom of the screen when we do not include age and gender. You'll see here that I included the average prediction for the event, misclassification rate, as well as true positive rate. And you'll notice that if I go over to the Roles tab here, you can actually see there are a lot of other options you can choose when comparing your two pipelines. What I want to point out here is the difference between the two pipelines, specifically for the true positive rate. So here we can see that when we do not include age and gender, the true positive rate for males is about 0.46%. However, when we look at the pipeline that does in fact include age and gender, we see that this actually drops to 0.1667. So we can see that overall, the model that includes age and gender actually looks to have an overall higher accuracy, where that isn't necessarily the case for the second model. However, it appears as though for males in particular, the model that doesn't include age and gender may actually be more fair. And so I'm not here to necessarily give you the right answer, but I am here to show you that with VA and with Model Studio, you have the tools to be able to do your accuracy and fairness comparison.
Wow, there's a lot there. You have been busy. Thank you. And obviously, it's not you alone, and you're working a lot of time, a lot of hours being put in with our engineering team, the product management teams, and we're not done yet. Like we're just showing a few here, but we've got a whole, as we just call it, the capabilities landscape, which highlights 6 kind of significant capabilities that we think are necessary in the trustworthy marketplace, from privacy and security to mitigation to data management, model ops, and so on and so forth. So great job. I'm looking forward to what you guys have cooking next. And oh, by the way, what you got cooking next?
Oh man, you're going to put me on the spot like this. So to your point, we do already have so many great features, right? And I think, I'm really excited to start thinking about, where our gaps are and trying to sort of fill those things in. Because when I think about developing my own algorithms as a data scientist on this platform, I want to make it easier for people like me to be able to walk through the process and not have to worry that they missed something, right? And I think the biggest thing that we are going to try to do is create as many features as we can to make it easy for data scientists, business users, et cetera, to do their work in a responsible way and to make sure that they're not missing anything obvious, things that they should be considering, throughout the platform. So I think that that's going to be really valuable moving forward.
Cool. Well, I often say unintended harms occur in this space. Right. I've never walked into a conference room and seen a diabolical plan on anyone's whiteboard. Right. That said, unintended harms have every bit as much impact, if not more, as intentional ones. And so to the extent that we can put a platform in place to help people mitigate some of those unintended harms as they're out in the world trying to do the right thing, then I think we're in the right space. So thank you again for all the time. And I hope it was beneficial to our SaaS Explore folks. Take care. Thanks.